Hi, everyone. I'm Patrick McFadin, Apache Cassandra committer.
And my name is Davor Bonaci. I'm the VP at DataStax and have been working in the data and ML space for a while, from Google, starting a company and exiting to DataStax. And I'm excited to be with you here today, talking about what's next for Apache Cassandra with such a great speaker like Patrick.
Yeah, so Davor, let's talk about what's new for Apache Cassandra use cases. And this is going to be a fun talk, I think. So let's go. So we have two growing trends for Cassandra. If you're paying attention in the community, they may be somewhat obvious, but there's another part that isn't. So when we talk about growing trends, Cassandra has been a transactional database for a long time. And so that's been more of the traditional use cases, back in your web app or your mobile app or something like that. And that's a great use case for Cassandra because it's a database that stays online, it's fast, it scales, it does all those things. But just like everything else, things change. The industry changes, we move forward. And so as a database, we're going to start moving forward as well, because this is just what our industry does. So the first actual big trend that we can see with this is cloud native. And when I say cloud native, I know that's a huge topic, but it's about how we use Cassandra and as projects like Cassandra, but it's also deploying Cassandra in the cloud, using Cassandra in the cloud, API based, making it easy to do security. And I think this is what we see in cloud native, which is making things simpler. And again, this is the theme for Cassandra Forward is how are we making things simpler? How are we making it more accessible for everyone? Cloud native is trying to make that happen for everybody. And everybody gets an access via just an API. Instead of having to install it, say, on your laptop or having to manually install things, Cloud Native is going to open up a lot more use cases just from ease of use. The other one, which is not quite as obvious, and this is what we're here to talk about, is how Cassandra is backing a lot of AI and ML use cases. And this is not a surprise for some of you, but probably a surprise for a lot of you. And that's just because the largest companies in the world have been doing this already. If you think of like the companies that have been using Cassandra for a long time, which is like Netflix's and Uber's, actually exactly Netflix and Uber, those are two companies that have been doing things with Cassandra for a long time in the transactional space. But now they're using Cassandra for other things, and it's backing machine learning. So when you're using Netflix or when you're using Uber, yes, you're getting transactional data right out of Cassandra, but they're also using that transactional data in really useful and new ways. And that's what we want to show off today a little bit. And it's not something that they talk a lot about. Uber has, and they've talked a lot about this project they call Michelangelo, but this is exactly what where they're making a difference with AI and ML workloads with something like Cassandra. Now, we could talk about how they traditionally work, but this is an actual slide from the Michelangelo team at Uber, and how you could see Cassandra being mixed in all over the place as a feature store, as a model repo, where their actual data is. So if you think about when you're using Uber and you're creating data by taking rides or doing Uber Eats or things like that, it goes through this system. And this has been some of their secret sauce for a long time. This has been around for a long time. And you get to use Cassandra every day in new ways, but what about you? So let's get into this. Like, I think this is probably one of the things that you can see out there today. And that is, we talk about this project called Feast, and you may have heard some discussion about it in the Cassandra world, because Feast is adopting Cassandra as a model repo. Feast was brought from the teams from Uber and Gojek, and so some of the Michelangelo team is actually working on Feast. This is something you can do today, and it uses Cassandra, obviously. So that's just something you can go play with today. But there's more to this, I think. So, Davor, why? I mean, let's get into that. Like, they're obviously, these companies are investing a lot of engineering time and they're doing some really cool work. But why would they do this other than it's a cool thing to put on HackerNet?
Yeah, so I think it's a great topic to start with. Is around talking why. What's the business use case of real-time ML, and particularly real-time ML on operational data in Cassandra? I think it comes down to realization that most of the impact from recommendations, from personalization, comes from data that is very recent. That fundamentally, when we open an app or open a website, we are here to complete a task, to complete a job. And when we come tomorrow, we come in a different context. And if machine learning is going to help us, it has to do something within the session. And this is where it comes down to in-session personalization. And you see that in so many things, right? So Netflix is here on the slide, but you can imagine a use case where you like one genre of movies, but you have tonight somebody coming over and you're looking for something else. Your session is different than your normal thing because you have somebody coming over. Or in e-commerce world, you may be buying something for yourself, but when you're buying a gift, it does not follow the pattern. It's a different session. So in so many cases, you will find that why we come to a digital experience is to complete a task. And even though we have certain tasks that we do frequently, there are many sessions and many opportunities that don't follow the pattern. And if we build quality models that can actually provide in-session personalization, really real-time ML, we can make a difference. And what people have been figuring out how to do this on top of Cassandra and other systems has been really amazing. And I think, pioneers in this space have been on this journey for a while. And, Patrick and I are excited to bring this type of technology to everybody, to make it easy to achieve these types of results, in-session personalization, real impact with machine learning, easily to everyone. Patrick?
So Davor, I mean, I think Netflix is pretty famous for their recommendations. Like so many years ago, I remember they had their some sort of a contest where they were trying to get like 0.1% better recommendation. But that was something that was done in a batch, that was done in the back end. I think they even used Hadoop, right? So like Netflix has been already established in this world, but of course they want to use on Cassandra because that's where all their transactional data is. But maybe you could talk about how we got here.
Yeah, so for sure. All right, like obviously ML is hard. You have to do a lot of data processing, training, doing it at scale is difficult, right? And so obviously when people started on this process, there was a more like a standard architecture of how to do it, which typically include putting data as it comes into a data warehouse of some kind, doing some feature transformations, populating a feature store, training the model, figuring out some predictions, putting it perhaps in some kind of production level store, and then calling that production level store from the API. This is kind of how people usually started, a few years ago. And this worked. Obviously, some people found success, and it's not particularly, surprising, but obviously there is increased cost in how this is run, complexity, and there is a latency from kind of events coming in to predictions coming out, right? Which diminishes the impact of the whole infrastructure. And so while this is achievable today, there are lots of software that help you do this, right? Like we are looking to increase the impact and reduce the cost and complexity at the same time.
So this is what I think most of us have thought about. Like this is where data scientists live and things like that. But this is also like, if I like to use your Netflix analogy, like whenever I'm watching movies and all of a sudden I change my genre, like I think you used an example, like I love documentaries and a friend comes over and I start watching comedies. I don't want it to start recommending comedies in a couple of weeks. Like I think I need that happening a lot faster. So this will not work, right?
This type of system will have, like, if this is a nightly job, as it's kind of figured out here, right? Like the minimum latency would be, 1 day type of thing, or average latency would be 1 day, unless you are just around midnight, perhaps, doing something. right? And so we can definitely do better. We can simplify, yet increase the impact with kind of newer approaches to this, problems of real-time ML. And then, Patrick and I are excited to be working on this problem of machine learning on Cassandra, right? It's really about bringing machine learning to where the data is. Obviously, this data is super powerful. It's transactional data that captures users' actions, users' interests. By this operational data kind of reveals what the user wants, and that is really powerful in a machine learning use case. And so what we can do is obviously use more kind of real-time systems, event-based data, streaming systems to extract features faster as the data comes in, and populate an online feature store that can, using something like a real-time prediction service, give real-time predictions that we can call from the application, and kind of have real-time predictions. Obviously, we are not talking about training in real time. Training still happens, periodically, right, for drift and other reasons, nightly, weekly, or whatever the kind of business requirements need, right? So that is still happening periodically, not in real time, but we are providing real-time data, real-time features to models, which then produce real-time predictions. And obviously here we can have things like in-session personalization, where like end-to-end latencies are kind of quite low, right? Like sub-second latencies that can kind of obviously increase impact, simplify the architecture of the entire system. But really, it's about increased impact. It's about what personalization is possible and what is the business impact of those personalizations that we are most excited about.
Yeah, I used to call these people the data procrastinators, but Cassandra people are not procrastinators. It's how many petabytes of data is out there in Cassandra databases, and moving a petabyte of data to where you need to do analytics, that's pretty expensive and impossible, I think. So I love the idea of like, hey, Cassandra's sitting here, it's doing its work. So let's bring the ML to where the data is.
All right. And talk a little bit about Cascada. So before starting at DataStax, I was co-founder and CEO of Cascada, which built a really key component of this real-time ML stack. It's really an iterative feature engine built for real-time, right? It can connect once to event-based data, including real-time event-based data, compute features easily, which is like aggregations over this event data, and then connect them to any kind of real-time serving system or a prediction service to produce real-time predictions, right? And so we can create and serve features at scale from massive amounts of event-based data. The key thing of making this work, in our opinion, is about certain unique time-based capabilities. It's about calculating features at the right point in time, labeling them at another point in time, and then serving them, in the future. So why does this matter? Like, let's talk for a second, like how these models from event-based data work. It's about the model is capable of predicting the future by looking in the past who has or which situations match the context, match the experience, match the situation that the user is facing. And then obviously statistically we know what happens. It's really about learning from past behavior, from past users that were in a similar context, that exhibited similar behavior inside the application, that we can see and predict what is going to happen in the future. And so that insight enables that really good models are built from this data type. It's about calculating features at the right points in time and extracting context in those features, right? Because that gives behavioral traits that help us predict the future when new users face similar situations. right? That's key. And Cascada technology makes it easy to do that from Jupyter notebooks and Python client libraries, and making it easy to do it reliably in production where features are checked in as code. And I've been working on this system for a while now, and we are kind of excited to bring it in and integrate it with the rest of Cassandra community across the board. Patrick.
So I love the idea of time-based data, because time series data and Cassandra have been a thing for so long, right? And but I always say all data is eventually time series data, right? It's like, when did it happen and what point of time, especially transaction data. So like in the case of like going back to this Netflix example, like, is this where we look at what I have watched over time and trying to make something new out of that information? Or like, how would that fit in with that model? Like, I just changed my viewing habits.
Yeah. So how the model will work is the model will find other people in the past who have done similar behavioral shift. So imagine you love documentaries, right? You're not the only person in the world that loves documentaries. And then you kind of on one day start searching for comedies. Trust me, you are not the first person who likes the documentaries and started searching for comedies one day. There is like a lot of people in the world.
Good. I don't feel like I'm called out then. Okay, because that's my move, right?
Right. So there are many people who have done that usage pattern in the past. And the event-based data contains information about, did you actually watch the movie to the end? Did you not? What did you do about it? Did you switch after, like, were certain types of movies more liked than others from people that used to that watch more documentaries at the same time, right? All of that is available in historical data from other people facing that context shift, that context change. And because of that, the model can pick up on these things when we do features right, and then it can predict what is helpful to you right now. What is the good recommendation that you actually like, enjoy, have a good time, and come back? That's the power that the model can do, because the data contains information from other people going to the same journey. And we know what was successful in the past and what wasn't. So we can give you a good advice and good recommendation right now for you.
That's really cool, because I feel like that's actually a little more human. It's not so rigid. It's taking advantage of the fact that I'm kind of random. Humans are random. We do things, we change up our abilities, but other people do that too. So, I mean, that's really cool. And all that data will be in Cassandra. That is in Cassandra.
Yeah, totally. Right. So this is pretty easy, right? We connect to real-time events, compute features, store features, pass it through a prediction service, get real-time predictions. It's pretty easy, right? Like, the technology has matured that this should be achievable to all of us inside kind of data communities, particularly Cassandra community, given that Cassandra has been an operational store for this data for a long time.
That's really cool. I mean, I think this has been a theme with Cassandra Forward, and making this easy. This is going to help so many folks, because it hasn't been easy up to this point, right? I mean, you've got to have a lot of background. I mean, look at all the top jobs and the hiring and the big companies that are doing it. They're looking for lots of experience and the top engineers to pull this off. So is that where we're headed in the future? This is just so easy that it's just like any other function you use in programming?
I mean, certainly we are going down this path, right? So if you want to build a cool app, right, like, it's no longer that the app is just, a real-time app that produces, reasonable information that is up to date. It is about how to build smart apps that have a flywheel, that take off, the apps that get smarter with usage. We just talked about this Netflix use case, right? Like, imagine an app starting from zero. Obviously, you don't have data, but as soon as the data comes in, we know what works, and we can steer our users in a journey that actually gets them to succeed, gets them to come back, right? And it's very hard, I think, going to be in the future to succeed with an app without these smart capabilities that kind of get you into the right journey to succeed, to like the app, right? And so obviously, I think we are chasing how easy we can make it to empower people to build really good high growth apps that kind of become smarter as more people use it, and obviously that creates a flywheel that makes the app thrive, right? And I think that's a really good vision that I think we are on.
Yeah, because I mean, I can't think of an app that wouldn't need this in the future. I mean, every app that I use has some sort of machine learning AI component in it at this point. Even my stopwatch, I think.
And then kind of we can make an announcement here, I think, in conclusion, that everything that we talked about here is or will very shortly be open source. So the entire Cascada system is coming to open source this month. So the entire core of the system to compute real-time features, increasing access to real-time AI, available as part of open source, immediately innovating together, getting contributions. And so we are excited to bring this technology to and integrate deeply with the Cassandra community.
That's the great way to end this. Is like, yeah, all that cool stuff, open source, and that's what really makes it easier for people to use. It's that free as in freedom, free as in beer. There you go. And I'm really excited that this is happening soon. And I guess it's just watch this space. It'll be announced soon.
All right.
All right. Well, I think we're at the end of this presentation. So Davor, thanks for joining me today. And this has been it's exciting to end on this note. Really cool.
It was great being with you, Patrick, and look forward to doing many of these in the months and years to come.
Great. Well, thanks everyone for joining us for this session. And thanks again for joining us for Cassandra Forward. And we'll see you out there soon.